Hello everyone, welcome to this video channel. Today I am here to explain DevOps CI/CD architecture which you can use in your current environment to deploy microservices and application to OpenShift or Kubernetes cluster. My name is Sumit Kadyan. I have 14 years of experience in multi-cloud and automation. Before explaining architecture, let's discuss about CI/CD pipeline. CI/CD is continuous integration and continuous deployment or delivery, which help us to automate software deployment. Through CI/CD, we can do end-to-end automation. Whenever we are writing any kind of CI/CD pipeline, that time we write workflow. In the workflow, we write down the stages. In each stage, we mention some sort of action. For instance, if we need to deploy any application, that time we may need to write down stages such as like we need to build a package. Once the package is created, then we need to do some sort of testing. As an example, we may need to do some sort of unit testing, or we may need to integrate with some code quality tool. Once this kind of testing is done, then we need to push our build to artifact storage. Post that we can create a Docker image, and later we can deploy in any environment. Environment means you can deploy in virtual machine, or you can deploy in Kubernetes or OpenShift cluster, or in any cloud. It has multiple features. It helps us to ensure faster release along with some better code quality. Through this kind of process, we can get the immediate feedback, and also eliminate the manual errors. These are the prominent one. It has multiple other features as well, which we can learn uh, when we will be explaining the CI/CD architecture. Now let's discuss about what tech stack we can use to deploy application or microservices to Kubernetes or OpenShift cluster. These are the prominent one which we should use definitely. First one is the GitHub. It is a source code management tool, or I can say that it's a source code version control system where developer push the code. It provides multiple features uh, like branch protection policies, code review, etc. Once your code is available in GitHub tool, then you can write down your CI/CD pipeline using GitHub Actions. This feature is provided inbuilt in GitHub. That tool you can, I will say that feature you can use to write down your workflows using YAML file. In workflows, we write down multiple jobs. Let's consider that we are creating two jobs. In first job, we can mention multiple stages like create a package, test package, and create a Docker images as well. Once these stages are completed, then you can trigger your second job. In second job, we can deploy our application to Kubernetes or OpenShift cluster. The third tool is the Maven. Maven is widely used to build Java based applications. Okay, so this is the tool which you can mention in your workflows when you are creating or creating a package or building applications. So while building a packages, then you can also integrate with SonarQube, through which you can check your code quality. SonarQube is an open source tool which help us to detect vulnerabilities, bugs, and any smells. If everything is fine, like if there are no vulnerabilities, code quality is okay, then you can push your artifacts to Nexus repository. It is also an open source tool. In this we can create multiple kind of repositories. For example, if you want to store war file, for war file we can create different repository. For jar file we can create different repository. And we can also utilize for this Nexus repository to store Docker images as well. Okay, the third one is the Docker. The Docker also used to create some sort of consistent applications. It provides also a package that is lightweight, which is portable as well. And once we use this Docker, through that we can create a Docker images. And that Docker images we can either push to Nexus repository or OpenShift registry. It depends on the scenarios. If we are using Kubernetes, as we know that in Kubernetes we do not have any default repositories, so we can push the Docker images to Nexus repository. If we are using the OpenShift cluster, then OpenShift provides default registry. We can push Docker images to the OpenShift registry as well. Again, I'm reiterating, if we are using Kubernetes, then we may use the Nexus repository to store our Docker images. If we are deploying application to OpenShift cluster, then OpenShift provides its default registry which we can use to store the same Docker images. We can use OpenShift and Kubernetes cluster for deploying applications and managing applications as well. Kubernetes ensure high availability, scaling, and auto healing features. And OpenShift extends Kubernetes for security and developer friendly features. We can also use Helm charts for deploying applications again to OpenShift or Kubernetes cluster. It provide us parameterized based deployments and also gives features of version control, and we can roll back whenever we want if in case of any failure. For CI/CD architecture, we are considering three type of repository. One is developer repository, second is platform repository, and third is the Helm chart repository. In developer repository, we will store source code. We are considering that we would be using different microservices. For instance, if we are deploying 10 microservices, then we have to create 10 different developer repositories. So this kind of modular approach we are considering. In second platform repository, in that one we will be storing application related properties and infrastructure related properties as well. So in this platform repository we would be writing CD pipeline. That CD pipeline will be using those properties file and inject those properties file, I can say that in the form of config map, and it will deploy to respective environments. For each environment we would be keeping different properties file. Uh, Third repository is the Helm chart repository. In this repository we will write Helm chart templates. Okay, for in that Helm chart templates, as we know that it is written in which we can write into YML format, and those Helm charts templates are parameterized basically. So according to applications we would be creating different version of Helm charts. So in CD pipeline we would be using different versions according to application requirements. For instance, in one application, it may be some specific resource requirement is there, and we know that that resource exists in specific Helm chart version. So in the CD pipeline, we can mention that specific Helm chart version, and we can utilize that version to fulfill application requirement. Maybe in another application, that specific resource is not required, so then we do not need to use the existing one Helm chart version. Maybe we can use the different one. So that kind of sort of solution we can implement by using these three type of repositories. Now let's discuss about CI/CD architecture, which you can use to deploy microservices or applications to Kubernetes or OpenShift cluster. This is the architecture which I have created to explain in better way. Suppose at initial stage, developer push the code to microservices repositories. So then we can automatically trigger workflows that we have created in GitHub Actions. So previously I have explained why we are using GitHub Actions. So GitHub Actions we are utilizing to write down CI/CD pipelines. So once we are writing CI/CD pipeline, in that we can write multiple stages. At first stage we can build applications using maven build command. Once it is succeeded, then we can integrate with SonarQube, which will check code quality. If it is fine, the result is up to mark, then we can push artifacts to Nexus repositories. Suppose that we have to decide that where we are deploying application. I mean, we are deploying application to OpenShift cluster or Kubernetes cluster. If we are deploying application to Kubernetes cluster, then we can use Docker CLI command to create a Docker image. Once Docker image is created, then we can push that Docker image to Nexus repository. In the Nexus repository, we can create one Docker repository as well, and in that Docker repositories we can store Docker images which we are creating using Docker CLI command. So that option we can use when we are deploying to Kubernetes cluster. In case if we are deploying to OpenShift cluster, then we can use this path. I mean, we can use OpenShift build config that is provided by OpenShift itself. So there it will automatically download source code and it will create a Docker image as well. And in this build config, we can also mention that where it will push Docker image. So if we are deploying to OpenShift cluster, then we can use OpenShift global registry feature. As a best practice, we should deploy OpenShift global registry in different OpenShift cluster. If you do not want opt this feature, then OpenShift provide its default registry as well. There you can push the code. But again, Red Hat recommends that we should keep our registry in different cluster, because if in case the default OpenShift cluster fails due to XYZ reason, then our all images will be also lost. So to avoid this kind of scenario, we should keep OpenShift global registry in different cluster. So once our Docker image is there, then we have to change image tag, the image tag which we have created. That image tag we have to change into platform repository. In platform repository, we are keeping different values .yml file for different environments. Suppose we are deploying applications to dev environment. So in dev values.yml file, we have to change image tag. So then sort of actions or steps we can write in our CI pipeline, which will change image tag to platform repository to uh, the respective properties file. For instance, right now we are deploying to dev environment, then we have to change in dev values.yml file. Once the file is changed, I mean the Docker image tag is changed, then we can trigger again new CD workflow automatically, which will use helm upgrade or install command. During this running this command, it will also download helm chart specific version. Okay, so it will download and it will pass that value.yml file to that specific chart version and deploy to OpenShift or Kubernetes cluster. So again, if we are changing into values.yml file of dev environment, then we can deploy it to dev environment only. Now let's consider second scenario. If you want to deploy in upper environment such as UAT, QA and prod, then we can manually trigger. In that we can select like if you to which environment we want to deploy. Suppose if we want to deploy to QA environment, so select QA environment, enter specific image tag which you want to deploy. Here we can enable that option. It is not mandatory to specify image tag here. If you leave empty, then it will automatically check lower environment. In lower environment, which image tag version is specified, it will pick that image tag and it will ask for approval to change in QA values.yml file. If platform lead or architect approves it, then it will change that image tag to specific QA values.yml file and it will trigger workflow. Again, it will download specific chart version and it will apply those value.yml file along with that chart version to QA environment. So again, likewise, we can deploy application to UAT and prod environment. This is the simple CI/CD architecture which we can use. And we can also modify as per application requirement as well. At later stage, you can also add some sort of integration testing as well. Once it is deployed in QA environment, then we can execute some sort of scripts which will basically do some sort of integration testing as well. And we can also enable notification, like it is deployed in QA environment successfully, test cases has been executed successfully. That kind of notification we can send to respective team members. Thank you so much.